Okay, this is the last lesson in rational exponents and radicals. We are finding the inverse, which is not the first time that you've seen that. You are going to solve for the inverse the same way that you solve for inverses in all of the other previous functions that we've covered. You're going to switch your x and your y. That is your main step. You switch your x and your y and you solve for y. So if I do that, I started out with this equation, and I'm going to switch my x and my y. I am not going to do anything else to my equation. And I'm going to solve for my y. So I have to get that y by itself. So first thing I'm going to do is I'm going to move 5 over. Second thing I'm going to do is I'm going to divide by 2. So now I have this equation left on the right. So I'm going to take the cube root. So I'm left with 3y minus 4. I'm going to add 4, which would be cube root x plus 5 over 2. I'm going to add 4. And then I have to divide everything by 3. So I'm going to multiply by a third, 1/3. And I'm also going to multiply 4 times 1/3, which would give me 4/3. And that is going to be my inverse. So the inverse of a cube function would be the cube root function. That is my inverse. So on the next one, find the inverse of y equals x squared minus 2. And it restricts your domain, your x. And the reason is, you're going to see in just a minute, is that I'm going to switch my x and my y. If I do not restrict my domain at the beginning, what will happen is that my inverse would not be a function had I not restricted. So you're going to take whatever this is and set it greater than or equal to 0. So if you will look at your graph, this would be x squared minus 2. That means that it's been moved down 2 units. It's a quadratic parent function. So if I go up or right 1, I go up 1. If I go left 1, I go up 1. Over 2, I would go up 4. Over 2, up 4. I'm going off my parent function table. So this is the graph of x squared minus 2 without any restrictions. Well, that's a function. My inverse is going to be reflected over y equals x. If I do not restrict this original function, when I reflect it, it's going to be on its side, and it's not going to be a function, because this would be reflected like this. And that's not a function. It does not pass the vertical line test. But if I restrict it and only look at half of it, then my inverse is going to be a function. So if I, hang on just 1 minute. Hang on, guys, just a second. Sorry. So this would be, this has been moved left 2. Now I'm doing this one. This would be moved left 2. And you can see that on my quadratic, I'm only looking at half, and the half that I'm looking at would be the right side where x is greater than or equal to 0. I'm not looking at this. I'm looking at only this. So for my original graph, the domain would be from 0 to positive infinity. And my range is going to be from -2 to positive infinity. Well, when you take the inverse, the domain of your original is going to become the range of your new one. So that means that my range is going to be from 0 to positive infinity, and my domain for my inverse is going to be from -2 to 0, infinity. So when we go to graph this, it starts at -2. It's been moved left 2. So it's starting here, and this is a square root function, so that means I go over 1, up 1. I go over 4, up 2. And this is my graph of my square root. So these two functions are reflected over the y equals x line. So when you're dealing with inverse, the inverse of a quadratic is a square root function. Your domain, you have to restrict your domain of your original so that your inverse is a function. That's what we're trying to do. If you hadn't have restricted, then the inverse would not be a function. Okay, so we are going to graph the inverse of the function, which we have this is a square root curve, but it has been reflected. So we're going to take the points that we know, which are 0, 1, 2, 3, 4, 5. This is 0, 5. So you're going to label your points. And that's all we need. We know that my inverse function is going to look like this. We're going to flip the points. So 0, 5 becomes 5, 0. 1, 4 becomes 4, 1. And my graph is going to look like this. It's reflected over the y equals x. This is a square root. So what does it want? Write the equation of both. So if I take my original function, which is the purple one, I have 0, 5, which is my hk, and 1, 4 is my xy. So this would be, I'm going to use this equation. So plug in 4 equals a 1 minus 0 plus 5. So this would be -1 square root of 1. So a is equal to -1. My equation for my purple one is y equals negative x plus 5. That's the purple one. Your pink one is a squared. It's a quadratic. So this, all I'm going to do is I'm going to take, I forgot to do this. This is 5. If I want to switch my x and my y, so this would be x equals negative y plus 5. So this would be x minus 5. And then I have to multiply everything by negative. and then I have to square. And this is my inverse. Okay, so my two equations would be, this is my original, and this is my inverse. Okay, so on this one, I'm going to take that 3 away. So my domain for this square root would, my HK is 2/3 7, square root curve. The domain is going to be from 2/3 to positive infinity. My range is going to be from 7 to positive infinity. The inverse, the domain is going to be the range of the old one, and the range would be the domain of the old one. You just flip them. And so I'm going to find my inverse, switch the x and the y. Isolate, so I'm going to subtract the 7. Then I'm going to square, so I'm left with 3y minus 2. And then I have to add 2 and divide everything, oops, it's supposed to be 2. And then divide everything by 3. And that's your inverse. Okay, so this one, find the inverse, restrict the domain if necessary. Well, it's already been restricted. It's telling you that we're looking at the left side. So my inverse, this would be the domain, is going to be from negative infinity to 0. And this has not been moved up, so my range is going to be from 0 to positive infinity. Oh, except it's been reflected, so it's going to be the other way. So we're going to do this. So this graph is going to look like this. Oops. This. It's going to be half that curve. So this is going to be x equals negative y squared. I have to divide by negative. Take the square root. So my inverse is square root of negative x. And you can see I'm only looking, using my negative x values. So this, I would need to restrict the domain. I'm going to be looking at x is greater than or equal to 3. So you're going to switch. Right now, my domain is, well, it's x is greater than or equal to 3. So this is going to be divided by 2. I have to square and add 3. So my function is this. And you can see that it's been moved. Your range here would be y is greater than or equal to 0. this has to be restricted because of what's underneath the denominator, the radical. This is going to be a quadratic, but you're only going to see half of it because of your original square root. So really what you have to do is restrict on a quadratic to start out so that your inverse, which is going to be a square root, is going to be only half of your graph. So this one I have to restrict because I can't have a negative under the radical. So 2x minus 3 over 4 has to be greater than or equal to 0. 2x minus 3 has to be greater than 0. X has to be greater than or equal to 3/2. So your domain is going to be x is greater than or equal to 3/2. Your range is going to be this number. So let's do, this is your domain. Your domain is going to be your range of your new one. So let's see what happens. This would be x equals 2y minus 3. So x plus 2. I'm going to have to square. I don't want to write all my steps down like you guys. So add 2, and then I'm going to square to get rid of your square root. And I'm left with this. So I'm going to multiply by 4. And I'm going to end up with a quadratic. So this is going to be 4. I'm going to add 3. And I'm going to divide everything by 2. So I'm only looking at half of the graph. So your domain, you can see that it became your range because this has been moved up 3/2. Over here, your range was y is greater than or equal to -2, which means over in my new one, my domain is going to be from -2 to infinity. I'm only going to use from -2 to infinity. All right, on this one, I have to restrict again. The range is going to be from 1 to positive infinity. The domain, I have to restrict right here, would be from 3/2 to positive infinity. Well, that means that my new graph, my domain should be from 1 to infinity, and my range is going to be from 3/2 to infinity. Let's just see. So this is x equals 4, 2y minus 3 plus 1. So I have to subtract 1, divide by 4, square it, and I'm left with 2y minus 3. So I'm going to have to add 1, add 3, and divide everything by 2, and I'm going to multiply everything by 1/2. Oh, I messed up here. This is supposed to be 2. So I'm going to get rid of that 2. This would be 1/2, and this would be 3/2. So you can see that your range, it's been moved up 3/2. And then if you for this one, you're going to have your domain is right here, which is moving it to the right. It's on the inside, so it's moved right one. All right. So, in order for a function to, or an equation to be a function, it has to pass the horizontal line test. If it is the inverse, if you're checking to see if the inverse is a function, then you're going to do the vertical line test on the original. So determine if the function's inverse is a function. So we have absolute value looks like this. Well, your original, you're going to do your horizontal line test. A function is 1-to-1 if it passes the horizontal. So you're going to do a vertical line test on the original, horizontal on the original for it. I said that backwards a while ago. So for the original, it is a vertical line test. If for the inverse, you are still working off the original, and you're going to do a horizontal line test. And this V would clearly not pass that. So no, the inverse is not a function. The original is a function. This is a cube function. It's going to be this snake. So the original, I'm going off of the original. The original is a function. The inverse, you're going to do a horizontal line test. And a horizontal line test, it will pass. So yes, it is. The inverse of a cube root is a cubic. So both of those are functions. This quadratic is a function. And unless the inverse, because the inverse is going to be a square root, I would need to restrict my domain on my quadratic. If I don't restrict it, the inverse is not going to be a function. All right, so when you're checking to see if two functions are inverses of each other, you're going to use composition. It says right there, use composition. And when you use composition, you should end up with X, and you're going to have to try both of them. So I would put G in for F, and then I would put F in for G. So it would look like this, 3 1/3 X minus 1 squared minus 1. And this would be 1/3 3x squared minus 1 minus 1. So we have 1/3. I'm going to put 3x squared minus 1 right here, and you still have that negative 1. Okay, so this would be the squared. 3 is on the outside. 1/3. If I multiply 1/3 squared, that's 1/9. So this would be 1/3 square x minus 1. That's x minus 1 minus 1. Well, this is not going to be x because 1/3 times negative 1 minus 1. That's not going to cancel out. Same thing here. I've got 2 negative 1s. And then this would be the square root of 3, which that's not going to cancel out. So I've got a lot of things that are not going to cancel out. So these are not inverses. This one, five x cubed minus 9 plus 9 over 5 x plus 9 cubed minus 9. So these 9's cancel, this 5 cancel, the cube root of x cubed, that's x. This works. Then this, these things cancel, so you're left with 5 x plus 9 over 5 minus 9. Well, this 5 cancels, these 9's cancel, this is x. This is indeed inverses of each other. You have to end up with x for both of them. And those are your inverse lesson.